Here's just a couple more examples of the binomial theorem. I know that this is kind of tricky, especially the first time you hear it, but once you practice a few, I promise you'll get the hang of it. So this time we want to expand this binomial to the third power. It's similar to the first one we did, except you'll notice there's now a negative sign, and that's going to make things a little bit different. I mean, you follow the same process, but you'll see. So first thing I need to do is go find my coefficients from Pascal's triangle. Since the exponent is a 3, I'll go find the row in Pascal's triangle that starts with 1, 3. So that would be this one right here, 1, 3, 3, 1. You do need to know how to recreate Pascal's triangle. So like if this were on a test, I would need to, if I didn't remember it, I'd need to be like, okay, I start with my 1s, and then 1 plus 1 is 2, and then I have 1s on the outside. 2 plus 1 is 3, and 3, 1's on the outside, and that would be the row that I needed. So, okay, 1, 3, 3, 1. Now I'm going to put an X in each, and I'm going to put a -2 because it's negative. Make sure you use parentheses on this, because it's not -2, it's multiplying by a -2. Okay, now I need exponents, starting with 3, and then going down from there, 3, 2, 1, 0. And then I'll start with 3 on this end, 3, 2, 1, 0. These are all plus signs at first, but they might not end up that way once we simplify. Okay. On this one, anything to the 0 power is a 1. 1 times 1 is 1, so that's just x cubed. On this one, -2 to the first power is -2, and then -2 times 3 is -6 x squared. So that one actually just became negative. This one, -2 squared is -2 times -2, which is actually +4. 4 times 3 is 12. And x to the first is just x. Last one, we've got x to the 0, which is a 1, because anything to the 0 power is 1. And then -2 cubed would be -2 times -2 times -2, which is going to be a -8. And then -8 times 1 times another 1 is still just -8. Okay, so this is my final answer on this one. Notice a couple things. First of all, notice that the final coefficients typically don't match those coefficients that I pulled from Pascal's triangle, so they might change once you simplify. Also notice, because of this negative, I ended up having a few negatives down here as well. And this will actually always happen. You'll probably notice this pattern, but it's always going to alternate plus, minus by the time you're done because of those even and odd powers. So that's something you may want to explore if you get done early. Just a couple more examples. Something you might see would be not just to expand it, but what is the 5th term of expansion for this binomial right here? So like on this last one we just did, this would be the 1st term, the 2nd term, the 3rd term, and the 4th term. This one wants the 5th term. So I don't have to do the whole thing. I just need the 5th term. And so let's go ahead and get started. This is a 6, so I need the 6th row from Pascal's triangle. Let's think about what that would be. I start with 1s, and then I add. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 3 is 6. 4, 4, 1. I'm just adding. 1 plus 4 is 5. 4 plus 6 is 10. 4 plus 1 is 5. We're almost to row 6. 1 plus 5 is 6. 15, 20, 15. There we go. There it is. This is the row that I need. Took a little while. Okay, I only want the fifth term. So the fifth term is going to be, actually, let's write these out. 1, 6, 15, 20, 15, 6, 1. There's that row. But the fifth term is going to be this one. 1, 2, 3, 4, 5. I only care about this. So I don't have to do the rest of the work. I know that it's going to have a 2x. And I know it's going to have a 3. That 6 is getting in my way. Ignore the 6. And then I know with the exponents, I would start with the 6 over here and go 6, 5, 4, 3, 2. And I know I would start with a 6 over here on the 3, so it would be 6, 5, 4, and then 3, 2, 1, 0. But I don't need to do that other work unless you just really want to. So this is gonna be my answer once I simplify. I'll have 2 squared, which is 4, x squared is x squared, 3 to the 4th would be 81, and then times 15. I'm going to use my calculator on that one. Do 15 times 4 times 81, and you get 4860, and then x squared. So I didn't have to do the rest of that work. I found the fifth term, which is this. One final example here. This one asks, what is the coefficient of the fourth term of expansion? So on this one, I'm going to find the fourth term, and then I actually just want the coefficient, which is the number in the very front. Like on this one, the coefficient ended up being 4,860. So this is our last example. I need the fifth row of Pascal's triangle, which was this. 1, 5, 10, 10, 5, 1. But I only care about the fourth term, the 1, 2, 3, fourth term. All right, I know it's going to have a 3a. I know it's going to have a negative b. And I need the powers on those. So 5 would start over here, 5, 4, 3, 2. And 5 would start over here, 5, 4, 3. Ooh, fun fact, these exponents always end up adding to the power right there. Let's go back, look at one. Like on example 1, look, 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, and 0 plus 3 is 3. Cool little pattern there. Anyway. Okay, I've got what I need, just need to simplify. So 3 squared is 9, a squared. If I have a negative, that's technically like a negative 1. And negative 1 cubed would be negative 1 times negative 1 times negative 1, which ends up being negative 1. And then b cubed. And times 10. Okay, so that's 10 times 9 times negative 1. So negative 90 a squared b cubed. Remember, the problem only asked for the coefficient, so that's just the number in front, negative 90. The original was a 10, but by the time we were done simplifying, it was negative 90. So that is the binomial theorem.